Hi, I'm Bob Alsop with ShopSabre CNC. Around here they call me Routerbob. In this video, we're going to produce a solid wood stratocaster style guitar body. Let's get started. Building custom guitars with CNC routers has become quite an industry. I didn't really understand it at first, but when I modeled my first guitar neck, a light came on. Because here's what happens. The contour on the back of the guitar neck is actually controlled by two profiles, a top and a bottom one. And when you change those profiles, that changes the surface underneath. And I thought, wow, what if you had 10 variations of a guitar neck that had 10 different fits? So you could customize a guitar for a person and say, okay, now let me fit you for the neck, and here, try these on and see which one makes the most sense, and that's what I'm going to put in your guitar. Well, that's just the beginning. There's all kinds of other customization. It could be shape, it could be the material, it could be the finish, it could be the cutouts that you do for the electrical components. That's why this is such a great product to make with a CNC router. We can make this guitar body on something as simple as a ShopSabre 23. And that would be fine for prototyping, but there's a lot of tool changes involved, so that'd get old really quick. Probably where you'd want to go from a production standpoint is something like the ShopSabre Pro 404. That's a 4x4 machine, but it has an automatic tool changer. But what you get into, if you've got limited space, that's okay, but if you've got more space, a 408 makes more sense because the price difference between the two is not much. The difference is steel, which is the cheapest component in the machine. And so that would be an alternative. What we're going to do here today is we're actually going to use an IS 408, and it's got a couple of features that make sense. We're going to use our hybrid spoil board technology, so it's a vacuum table. It's also got part locator pins and, of course, a tool changer. So that's why I really selected that machine. And we want to address this as a production setup to make guitars. The setup we're going to use today involves a gasketed dedicated spoil board. And I wanted to actually be able to put it on and off the machine and locate it with a part locator pin. So think about this scenario. You've got this fixture board for making a specific product. You put it on the machine, it's automatically aligned. You run the product. When you're done, you take it off the machine, you store it. So the repeatability is determined by the part locator pins. I also selected a 4x8 table because I can also use it to cut pieces of plywood that I might need for a setup. Here's an example of a stratocaster body. This one's one I downloaded from the internet. It's actually modeled after a 1962 version because it has this little cutout here that was later eliminated. They just make this stuff deeper. What's interesting is you can probably find guitarists that think they sound better if they have that. But let's look at the geometry. Basically, it's 1 3/4 thick, and you can see the 3D part of it's really the roundovers here, that area, and then on the back side there's an area. That's really the only 3D part. The top and bottom are flat, and the overall it's about 1 3/4 thick. And then up here you've got some what I call 2.5D machining. Here's what that means. 2.5D means it's a shape at a certain depth. And so that's what these are. Now, these will vary based on the electrical pickups that you're going to use. So these will vary based because of customization. You almost always see the rest of this. There's always a cutout on the back. And so what we really need is we need the 3D model, but I'd prefer to have it without all these openings. And we just need a 2D drawing showing these this geometry. So that's probably what would be better. And we're going to actually toolpath this. I'm going to toolpath it with Aspire, but you can really do it with VCarve Pro. Let me show you how you get the 3D file into VCarve Pro. Okay, in VCarve Pro, you create a new file. Okay, you're going to have to define what size the material is going to be, and you have to figure out if it's a single-sided, double-sided, or rotary. To start out with, you're better off just do a single-sided and do a top file and a bottom file. That'll get you started. That's the easiest way. Okay, now my blank's going to be 15x20 by 1 3/4 inches. And the Z0 position is the top of the fixture board, and the lower corner is the origin. So we start there. Okay, now I'm going to come to the modeling tab, go to this, Okay, and I'm going to locate an STL that I created, and we're going to tell it to center it, and I'm going to say OK. Now it looks crazy, but here's what it did. It basically put a bottom and a top. So if we turn that off, there's our actual model. All right, so that's what it looks like. Now, if what determines where that is in the material is right here. If I go to this, okay, a gap, I want a 0 gap. In other words, I want that model all the way up to the surface. That's what that does. So that when you bring that model in, this determines where it actually goes in the volume of space. And remember, I want that surface to be flush with the top of the panel. Now in this one, I actually took out all of the 2.5D stuff, so all this is the 3D surface. Like I said earlier, the only thing we're going to use this for are these curved edges and these areas here. Here's a model in Aspire, and once again, you can do the same thing I'm doing here with VCarve Pro. I just started with Aspire on it. So here's the blank size, and then this is the model I brought in. And you notice this model doesn't have any of the cutouts in it because all I need is the 3D surface for this. Now this plane that you see here is added in there in order to control how deep you cut. So that controls how deep the ball nose can go when you're actually cutting these edges. And we'll hit OK. And now let's look at the 2D view, and you'll notice I've got some more geometry here. Now, this is the geometry I need. This is the 2.5D stuff. All right, let's take a look at it. This line right here, this is the outside of the guitar when it's finished. These two right here actually define where the 3D machining's done. So that's where the ball nose is going to be used because that's what's required anytime you're going to do 3D. Okay, and then this is actually a plate that goes on there, but this is a pocket that's cut in about 5, I believe it's 5/8 deep. And this one goes almost all the way through. So that's the geometry that we're going to use. And then you'll see some holes here, and I believe there's a hole here. So now, let's take a look at this, and let's look at the actual tool pass, and I'll show you what happens. First off, we start out, we're going to have a fixture board, and we're going to look at that in a minute, but basically I'm able to take that glued up blank, which has not been planed because I don't have a planer, and vacuum holds it down, and then I fly cut it. And fly cutting it basically makes it perfectly flat, just like fly cutting your spoil board. I prefer an 1.5 inch straight bit to do that with, and when it's done, the material is 1 7/8 inches thick. Then that gets turned over, held down with vacuum. Now that side's perfectly flat. And so the first thing I do on this operation is to face this. Let's take a look at that. And you're not going to be able to see it do anything because it thinks the blank's 1 3/4 inches, but it's actually thicker than that. So when you're done, this is uniform surface and it's a correct thickness. Okay, then we go to the pins. Now these are 2 holes. So we're going to drill 2 holes in there, and that's what causes it to align when you turn it over to the other side. Okay, then this is an outside cut, but it doesn't go all the way through. Primarily it's used to define the perimeter and also provide some clearance for the 3D cut. All right, it goes about 1 inch deep, so it doesn't go all the way through, and it's actually not the finished edge. There's about 40 thousandths around here, because we're going to do a final finish cut when both sides are done. And then this is the 3D finishing part right here. And this is what really takes the most time. Now, I decided I was going to do an experiment, and on the back side I used a 1/4 inch ball nose, on the front side a 3/8. And 3/8 definitely is the way to go. It's much, much faster. Okay, then we have the 2.5D stuff. Here's a shallow pocket. Once again, that's done with a 1/2 inch bit, and then here's the deep part of it. So that's the machining that's required to do the back side. So then the next step is to flip it over, put it on the pins, and then we'll look at the tool pathing on the front side. Okay, now this is the top side of the guitar body, so let's take a look at that tool pathing. First, we don't have to face this because it was already faced. So the first thing we're going to do is our outside cut. And once again, this is the same thing we did earlier, except this time it's actually going to be sticking through and it's going to intersect with the back side. So this center piece is separate at this point. Then we do our 3D finishing. That produces that surface. Then we're going to put a 3mm drill in here, We're going to drill these holes. Then we have a shallow pocket. And then we have a neck pocket. Those are all done with a 1/2" tool. And then we have a deep pocket. And that one goes almost all the way through the blank. And then finally we do our outside final cut. All right, what that does is that actually removes that 40 thousandths that we had left over, and that gives us a beautiful smooth surface on here. And that's really all that's required to do the guitar. Okay, now let's shift our focus over into how we're actually going to hold this part. And this is how we create a gasketed dedicated fixture. And here's where it begins. You start with the shape first, and then you figure out where can you have vacuum access. So let me show you what you got here. This is actually the outside of the body, and these two marks are what we use to define where we're going to do the 3D part. All right, then this was a cutout here. And then we also have this is where one of the pinholes was, and here's the other one. So now what we want to do is we want this to be held with vacuum. And basically what the geometry means is this. When you see these are grooves that are cut about 3/16 deep. Gasket goes in there, and the gasket is a 1/4 inch thick, so a 1/16 sticks up. Then you have grooves on the inside, and those are cut about a 1/4 inch deep. And then what you see here are holes, 1/4 inch holes, and those go down and they actually access vacuum underneath through the vacuum table, so it's all self-contained. So that's how that works. Let's take a look at the toolpaths on this. Okay, here's where we cut the blank, and what I'm doing here is actually defining where, you won't see it on here, but somewhere in the fixture board we have to know where to put the blank, because the blank may not be rectangular, it may be whatever size. All right, so that defined that even though you don't see it here. And then here's the gasket grooves. So those are the grooves that the gasket gets into, and if you notice there's no sharp corners, and the reason is if I put a sharp corner, I have to miter it. If I put radius corners, I can use one piece of gasketing, and it's much simpler. Then on the inside, here's the vacuum. So these are the channels for the vacuum itself. And then finally, here's the drills. And I don't drill all the way through because I'm afraid if I miss the position, I'll drill the table. So I drill to within about 1/8 inch on those. Then I take a hand drill and drill those through. So that's basically what holds with vacuum the part to the table. And once again, once you turn vacuum on, it's really strong. In our case on this machine, we also spec a Becker pump, because for this type of application, a Becker has tremendous holding power because the level of vacuum it supplies is really high. And since this is a contained system, you have the maximum effective vacuum. So far, all of our toolpathing has related to the lower left corner of the blank, but now let's talk about how we relate that to the machine. So what you see here, this is actually the machine table. This is our spoil board, which is 49 by 97. This is the fixture board, so it's 1/2 inch Baltic birch, and you can see where the pins are located that locate that. Now, but we got to know where to put this. If you notice, these are the holes that access vacuum, but how do I know that they line up correctly? Well, I happen to have a drawing I made that has all those on it. So zone 1 happens to be, those are the grooves where the vacuum channels are. So the way I select those locations is right here. I come over here where this intersects one of those lines, and that's where I put my circle, and that's what makes this all work. That's how I get vacuum from underneath the table up to the part. Now, so then the next question becomes, how do I shift the origin from here to here? And I'll show you how I did that. Let's start out first, and we'll turn this back off. Okay, when you turn the machine on and you tell it to go to G53 XY, it goes right here. That's where it thinks home is. In other words, that's called machine reference 0. All right, so now I've located this fixture based on the location of the vacuum access cuts in these holes. So I need to know where this is, because what I want to do is I want to shift the origin to right here. Well, how do I do that? Well, here's the easy way. Measure it. So I'm going to measure from here to here, and it tells me the distance in X and the distance in Y, and I write those down. So when we go out to the machine, I'm first going to type in G53XY. I'm going to set the XY 0 at that time. Then I'm going to jog the machine over to those coordinates, and I'm going to set the origin there. That's what makes this line up with the machine. Now we've got the toolpathing completed. Let's go out to the machine and cut the fixture board, and then let's make a guitar body. Let's start out by turning on vacuum zone 1. Next, we want to set the origin. Start by typing in G53XY and hit enter, and that'll move the machine to machine reference 0. Set your XY 0 at that point to start with. Now we're ready to run our setup program that cuts the grooves for the gasketing and the vacuum channels in our fixture board. Remove the fixture board and drill the vacuum access holes all the way through. Place the part locator pins and set the fixture board on them for alignment. Install gasketing in the fixture board. Begin by fly cutting the top of the blank and leave the thickness at 1.875. Now we're ready to turn the blank over and run the programs required to cut the bottom of the guitar body. Remove the blank, insert the dowel pins in the opposite corners, and position the blank on the dowel pins. Now run the program to cut the top of the guitar body. Our guitar body came out really nice. The machining's unbelievable. And the nice part about this, we approached this from a production standpoint. We didn't just make a guitar body, we actually looked at how you would fixture it for a production setup. And we used a fixture board with vacuum, and we also used our hybrid vacuum table system. Well, I hope you enjoyed the video. If you'd like to see more videos like this, be sure to subscribe to our YouTube channel. If you have any questions, you can contact us at shopsabre.com. Thank you for watching.